Today we are going to address about ASIC miners, the infamous miners that are used to mine Bitcoin, and can it be used for something else. Application specific integrated circuits or ASIC miners are designed with a singular focus to perform a specific computational task efficiently. In the context of Bitcoin, ASIC miners are engineered to solve SHA-256 cryptographic hash function, which is the core of Bitcoin's proof of work consensus mechanism. The specialization makes them incredibly powerful for Bitcoin mining but limits their utility for other tasks. Below, I'll explore whether ASIC miners can be repurposed for other activities, considering both technical feasibility and practical applications. Technical capabilities of ASIC miners. ASICs are hardware to execute a predefined algorithm, in Bitcoin's case SHA-256. Unlike general purpose hardware such as CPU or GPU, which can handle a wide variety of computation, ASIC miners lack flexibility. Their circuitry is optimized for one task, offering high speed and energy efficient but no programmability. This means they cannot be easily reprogrammed or adapted to perform different algorithms or functions without specific redesign, which is typically beyond the capability of end users. While ASIC miners are primarily built for Bitcoin mining, there are limited scenarios where they could be theoretically be applied elsewhere, provided the activity relies on SHA-256 algorithm or compatible tasks. Here are some possibilities. Bitcoin ASIC miners can mine other cryptocurrencies that use SHA-256 algorithm such as Bitcoin Cash, Bitcoin SV or Peercoin. This network operates on the same hashing principle, making hardware directly compatible. Practicality. This is the most common alternative. However, profitability depends on the coin's market value, network difficulty, and energy costs. For example, Bitcoin Cash has a lower hash rate than Bitcoin, but its price is also lower, often making it less lucrative unless Bitcoin mining becomes unprofitable. The second feasibility. SHA-256 is widely used in password hashing. That is, for example, in Unix systems or certain security protocols, ASIC miners could theoretically be deployed to brute force SHA-256 hashes, attempting to recover passwords or crack encrypted data. This is technically possible but impractical for most users. The setup would require custom software to feed hashes into ASIC and interpret results, a task far beyond typical mining firmware. Additionally, legal and ethical issues rise as this could be considered malicious activity. Specialized cracking hardware or GPUs are usually more versatile and cost effective for this purpose. Third, researchers studying SHA-256 properties could use ASIC miners to generate massive number of hashes quickly. Practicality. This is a niche and unlikely outside academic or security context. The hardware's lack of flexibility limits its use to SHA-256 specific experiments, and most researchers prefer programmable systems for broader analysis. Fourth, distributed computing projects. Some distributed computing projects, if designed to leverage SHA-256 hashing, could theoretically repurpose ASIC miners. For instance, a project searching for specific hash output might utilize them. No major distributed computing initiatives currently use SHA-256 in a way that aligns with ASIC miner capabilities. Adapting such projects could require significant redesign, making this impractical. Let's now see some of the non-computational uses. If repurposing for computation proves unfeasible, ASIC miners could theoretically serve alternative purposes unrelated to original function. Space heaters. ASIC miners generate significant heat due to their high consumption. Um, for example, 3000 watts for the top tier unit. Some users have used them to heat homes or greenhouse, offsetting electricity cost in cold climates. However, this is a byproduct and not primary use, and standalone heaters are far cheaper. Art or collectibles. Obsolete ASIC miners are sometimes sold as memorabilia or repurposed into art installation by cryptocurrency enthusiasts, though this is more of a novelty than utility. Now let's see some of the limitations and challenges. ASIC miners cannot mine cryptocurrencies using different algorithms. Adapting them for non-SHA tasks require building an entirely new ASIC, which defeats the purpose of repurposing existing hardware. Economic viability: the high initial cost and ongoing electricity expenses make ASIC miners uncompetitive for tasks where general purpose hardware suffices. For instance, a GPU costing $1000 can handle diverse workloads, while ASIC miners can sunk cost outside SHA 256 application. The third big limitation is the obsolescence. As Bitcoin mining difficulty increases, older ASIC mining becomes unprofitable and harder to repurpose, reducing their residual value for alternative uses. As miners are largely restricted to Bitcoin mining or mining other SHA-256 based cryptocurrencies like Bitcoin Cash and Bitcoin SV, and as their application specific integrated circuit design locks them into this single function. While niche applications like password cracking or cryptographic systems are theoretically possible, they require significant customization and are rarely practical. Non-computational uses such as heating or projected artistic projects exist but don't leverage the hardware's core capabilities. For anything beyond SHA-256, hashing general purpose hardware like CPUs and GPU are more versatile. In short, ASIC miners are one-trick pony, exceptional at their internet tasks but limited use elsewhere.